Hello, and thank you for contacting Wave. I see from your request that you're struggling with very steeply fitting lenses on these corneas, with central clearance and peripheral bearing. Well, if we look back at your topographies, unfortunately the difficulty is coming from lack of data in the topography. Unfortunately, as you may know, with these difficult corneas, these very steep corneas, quite often your topographer is going to miss the peripheral cornea. So in particular your left eye, this is very evident. You have basically captured the central steepened portion of the cornea, and so when you go to extrapolate this lens and prepare it for wave designing, the what you're going to be left with is a lens that, or a cornea, as at least the way Wave sees it, it's very steep from limbus to limbus. It doesn't really know that these areas that haven't been captured are a little flatter. As a result, you'll end up with lenses that are overly steep. Unfortunately, without peripheral data, there's not much you can do to use Wave to design the lens to match the topography. So you almost have to make empirical changes based on your clinical appearance. So if we look at this design, from your explanation, it sounds like the lenses are overly steep. So one thing I like to do in these difficult cases is just kind of click over on this RSIM button, and that will give you sort of the spherical equivalent, if you will, of the base curve. So if you click on the R, you'll see that the equivalent of this lens is about a 667. And you know that it's fitting rather steep. So to flatten it up, you can do a few different things. You can add a little asphericity in here. I like to try it to add that in, that helps out. You can also switch over to tangential. That usually flattens the lens out a little bit more. I'll leave it in free form, and then if I redesign this lens now, we'll give Wave a moment to come up with the design. And there we have it. Although the lens looks like it aligns very nicely on this corneal line, again, we can't really go by that too closely and not get too worked up about that line because we don't have a lot of real true data from that earlier topography. But if we do switch this lens over to that RSIM again, you'll notice that we flattened out to about almost 710 in the base curve from 667. So that should flatten this lens out very nicely. Now again, you're going to have to almost use an empirical approach. And what I like to do quite often, if I have the ability, is to put a known diagnostic contact lens from my regular fitting set on the eye, known parameters, so that way I can over-refract and get some true clinical data, and that'll help me guide me in some of the decision making. I think you're going to probably have to make a few adjustments as you go using some observational skills in your good old RGP fitting skills. In some cases, in these Wave cases, unfortunately I've had to go back to using a traditional lens only because it's hard to design such an exact lens on based on a topography that's not quite there completely. As far as powers go, you're also working with a very complicated prescription on a very complicated cornea. Sometimes what I'll do also is actually just fit a lens like this using RSIM to simplify the optics, and then place that lens on the eye, get an over refraction over that particular lens, and then plug that back in over here under tools. If I can, either under over refraction, or sometimes if I use a trial lens date, I'll use the trial lens tool. So hopefully you find that helpful. Again, this is a very difficult case because you don't have a whole lot of true corneal data to work with. I would use your fitting skills and some empirical adjustments to see if you can get those lenses to flatten out and fit a bit more nicely on the eye. Well, I wish you well with this difficult case, and thank you for contacting Wave.